So a couple of years ago, I got hired, the Ardent Studios got hired by Financial Apps to build a PFM, a personal finance management application. And that is called Power Wallet. That's been around for a few years. And with Power Wallet, it's similar to Mint, if you guys know Mint. So people can come on, they log in, they download their banking transactions, their credit cards, they can do their bills. And on the system, they can categorize all that, budget it, get bill reminders, all of that. So they're managing their financial lives on this system. And we realized pretty quickly that we had all this incredible consumer data, right? We knew what these people, where at least they were buying, the things they were buying. So to put that into perspective, we shot a short video, give you an idea of a user in Power Wallet.
Makeup.
So funny enough, you can't film in these stores, and we got kicked out of Walmart. So we wanted to do a scene where he was on the conveyor belt, and then we paid and got kicked out. Learned the hard way. But I'm here, so I didn't go to jail. All right, so that's a typical consumer for Power Wallet, right? For that day, he went out and he purchased a bunch of things. And so we have this database. This slide will go. Sorry, one more. So I have all of this data that we're gathering in the application. Right? We have in red all the user data, and this is typical to most of the applications that are out there, right? Registration, we can bring in social. You saw some of the financial data that we're pulling in. The application itself generates a bunch of data, impressions, alerts, budget, transactions, things that users are doing. And we wanted to make all of that data that's in yellow and red actionable. It was cool to have it, but not just for running reports. We want to make it actionable. We want to be able to do things. Specifically, if I know the gopher is online, and I'm looking at the fact that he's now has a girlfriend, I want to be able to target offers or advice or things to the gopher while he's online, specific to what we know about him as opposed to someone else's online. We want to make this data actionable. Now, I don't know about you, but my client at Financial Apps, the guy is an idea guy. You know the idea guys? The guys that every time you walk in on Monday, has been thinking about it all weekend and wants to do something like in the next 3 hours, right? That you can't do, and you're tired of saying no to them, right? So, guys got great ideas. And the first version of the system that I built was using a SQL server. And this caused a lot of problems for us. Because he would come in on Monday and say, Bill, I found this new feed. It's got all these great offers, and I want to start giving them to everybody. And I'm like, Bob, it sounds good, but I got to build a table. And after I build a table, I got to get that data in there. And then I got to make sure it's attached to the rest of the system. And by the time I do that, then I got to build some code. And then we've got to get it in there. So he'd be like, how long is that going to take? 3-4 weeks. Maybe if we're lucky, 2. If he told me to go do it, by the time I did it, I came in on Monday and we're all ready, and guess what? Bill, I found this great feed. I want to use it right now. Well, what about the one I just coded? Forget about that one. This one's better. So it wasn't working. We needed to find a way to be able to bring in these data feeds, this inventory, to allow others to bring in their own feeds, even if they weren't public, maybe like advice feeds internally. Be able to do that almost real time without having to build the system, without needing really a programmer to get involved. So we sat down and we said, if we had a system that would allow us to bring in dynamic feeds at the time Bob found them, to be able to bring them into the system and use them, but use them in the format that they're in. So a feed like a daily deal feed is very different than a credit card feed. Right? So a daily deal feed will have their deal ID, you'll have a description, you have a title, but when you get to a credit card feed, now you're talking about interest rates, APRs, a whole set of fields that were really impossible to map into the SQL server that dynamically and be able to query against it. But when we looked at Mongo, we realized very quickly we could build a collection on the fly. We could put the data that we're seeing in the format that it's in. All of the fields, we don't have to lose any of it, and put it in there, and it would be usable right away. So we had everything there. Again, we didn't want to do any fields. New builds of the system. That was not acceptable. We were doing builds every 4 to 6 weeks. So like I said, by the time we got around to the build, Bob already had 3 other feeds and ideas that he wanted to get into the system. We also realized that we wanted to be able to write rules, be able to target each user with different rules, and we wanted to be able to change those rules on the fly. Perfect example is Valentine's Day is coming up. So maybe we want to be able to target something specific to that holiday on that particular Tuesday, but then on Wednesday go back to some other things that we were doing. And the best one was he didn't want to have me responsible for it. He didn't want to have to pay a developer that hourly rate to be able to do this. We wanted to be able to have a business intelligence person or someone to be able to come in and at least manage the rules. So it had to be at that level. Now, there's always a little bit of programming involved, but he didn't want to have someone who had to learn C, Go, all of that to get it to work. So we looked at MongoDB right away, and we realized that was going to work very well for us. We wanted to move the system from Windows to Linux, and we found Go. We realized very quickly Go was the right language to help us build the web APIs and the back ends. And we needed a web framework, and we ended up not settling, because I think it's great, BGO. We looked at a bunch of them. We just liked that MVC structure, and BGO really fit that well for us, and we went with that framework. So just 2 slides real quick about MongoDB and why it's so effective dealing with the data that we're getting, all this different data that we want to make actionable. Now, MongoDB, as we already heard from Steve and Gustavo, it's a document-based database. There's no schema. There's no real structure there. And you can, if you want, try to use MongoDB like a relational database. You could build these collections of different documents and link them together, like you see here. But the real power of Mongo is to create a collection with all of the data in that document that you need and make it the document itself is related to everything that's going on. So this user, there's the contact information, there's their access information. And when you do this, you also have better access to some of the tools. One of the things we're going to talk about today is the aggregation pipeline. And when you do that, you can really leverage some of that technology to query the data and aggregate that data. Now, in order to bring in the feeds, we had to build a dynamic system that we could configure that could say, go out to that website every day and pull down the latest version of the feeds, this inventory, and update the system so it's up to date. The daily deal feeds that we have run every 3 hours. So we needed a way of being able to build these tasks and schedule them and manage that, and we ended up going with Iron.io. So what you're looking, well, this is a slide, but I have a demo where I'm going to show you all this stuff a little bit. So here's a slide just showing you. We're using I.O. to run a couple of tasks to update the database with all the inventory that we're going to be using. So here were some of the things we needed to accomplish with the dynamic rules engine. So now we've got all that data coming in. Iron.io is running those tasks. We've got data. But for writing rules, we needed to do a few things. We needed to be able to write those rules and update those rules at runtime. I couldn't do a build. I need to be able to pass data into the rules because sometimes I need to know what screen somebody is on or something specific that maybe they're looking at on the screen, a budget item or a transaction. I wanted to be able to do data aggregations and group the data in order to be able to write these rules and be able to then build tests around the data that we get back, be able to take distinctive data sets, compare those as well, and then eventually the whole idea is to push that offer, that advice, that thing that we're looking to give to that user that's relevant. So the aggregation pipeline in MongoDB is, for me, it's brilliant. I really love it. It makes it really easy to build queries on a collection and aggregate that down to the data that you need. So here's an example of a collection of orders, and we're able to run a query that's going to filter on a status, and then we take that data set and it gets thrown into the pipeline again and filtered and aggregated more. So you just keep massaging that data to the point where you get it. And that's how the rules are going to work. So for the system I have right now, I have 3 types of rules that we can apply to relevance. This first one is a variable rule. So basically this is used for variable substitution, and we can also do tests on true or false. Because the whole idea of the rule is go and do some query. Did we get some data back? Is it the right data, true or false? It is, let's do something else. It is, let's do something else, until we get to the point where either everything was true and let's give that user this particular piece of data, or it's not, and maybe we try another rule. So here, we're just passing data in. You notice that everything looks like JSON, and it does. It's very compatible with the way the Mongo works, and it becomes very easy to translate these things into the Mango driver. Plus, this is something that maybe not a full-flown, heavy-duty developer can also handle. So we were also looking for that. And these are questions. When the user's on the user tab, when there's a budget item, these types of things we can resolve with that. Then we have actual pipeline queries that we can run through the aggregation pipeline. So we might have a question is, this is relevant to the user when he is younger than 40 years old, when that user is single, when that user has a Gmail account. So whatever we have on that we think is relevant for what we want to show on the screen. And we can generate these aggregation pipeline queries and say match user ID. That's a way of doing that variable substitution right there. So we can make sure that when we run this query, it's for that particular user. And we can say match it when the age of that user is less than 40. Same thing here with like user transactions. These are things I'm going to be demoing for you in a little bit. So now I want to look at what they've been purchasing. When they spent more than $20 this month on the movies, when they've had more than 5 transactions that were greater than $5, all of these things that you can think of that you're saying, this is relevant when this user's, we can do that. If we have the data, we can do it. And then the data becomes actionable. Now, the one thing, and MongoDB solved this in their latest version 2.6, I didn't have it yet, was the aggregation pipeline can only run against a single collection. So that restricted me on some of the rules that I could build because the rule was only going to be based on one collection of data. So I needed a way to be able to run an aggregation or some rules against one collection of data and run it on another collection of data and then compare those results together. In Mongo 2.6 now, when you run data through the aggregation pipeline, you can save it to another collection, which is great because all of the rules can then stay inside of Mongo. But prior to that, one of the things I experimented with was using the Go templates. Because from inside the Go code, when I ran that aggregation query, I had a data set that I was able to pass into the template framework. So I experimented a little bit with using Go templates to be able to do some basic rules around multiple aggregation data sets. But in the future, we're going to probably leverage more of the 2.6 support now for being able to create collections. But even with rules, I can use this system to do other data transformations with the data that I get. Because sometimes the users who use this system, we're building an API around this now, don't necessarily care about true or false. They may just want some data transformations too around these rules. So the rule is not, is this relevant? It could be, run this rule because I want this particular data set transformed in this particular way, based on all the data that we have. So knowing that we needed to do all of that, this is why we chose Go, MongoDB, and BGO. You guys can see that. And I'm going to give you guys now a little demo. Now, I violated the first rule. The Mongo database is sitting in Linode. So hopefully everything here is good. I'm going to just refresh this, make sure we're okay. Can you guys see that okay? So here's, let's see if that works. So this is a demo app. I built this just for the talk. Cool. And I'm over limited bandwidth, but that was good to refresh. So this is just a demo app. It shows you how the system works. The system's built now on a set of APIs that eventually anyone will be able to consume. That's what the new financial data platform is going to be. So others can either build their own PFM or integrate into their own apps some aspects of this PFM data and relevance. So here's Gordon. Oh, I call him Gordon. And here are some of the transactions that we saw in the video that he did. So he bought the groceries at Walmart. He took some cash out, Best Buy, Chevron, Fandango, Regal. You see all of those transactions. And now I have these, and I want to be able to target an offer to him based on these transactions. So the idea is that he could be on this screen, and we make this call to the relevancy engine, and it says, okay, right now it's giving him some vouchers on restaurants. And we're going to see that rule in a second. But that's the idea, is based on that data that we see there, we were able to say, this is the offer that we want to give him. And we can change that on the fly. So here's like a pretty print view of the rule that I just ran to bring back that offer. You'll see that the variable is that we're on the user tab. I wanted to say for this particular user, the first rule says that they have to be less than 40 years old, and we're pulling it out of the demo users collection. If that's true, we run the next rule, and the next rule says, okay, against the transactions, any transactions they have that are movies, and let's aggregate those amounts. That group right there allows us to do aggregation. So now I'm getting a sum of all the money that he spent on the category movies. And then I'm saying, okay, if that sum is greater than $20, all right, we're good. Let's keep going. So far, this is going to be relevant. I do another one here for dining. These are very simple, just for the demo. These can get fairly complex. And then I'm comparing the two sums using a template to validate some more rules. And if everything is true, then we go into the the Lipid Feed, which is a daily deal feed that we have, and we find an offer for restaurants, and we give it to that user. So here is just some code that I can play with to show you some things here. So if I take this pipeline query right here in raw JSON, sorry, I built something here so we can test it. So I'm going to run this query right here through the aggregation pipeline. We're going to run that match the group. In fact, what I'm going to do is okay. So that negative I put in there because it helps me say don't run this piece yet. So all we're running right now is the first match. And the first match says, find me the categories for movie. Right now it's just returning the one. You see the $15.60. If I go back to that first tab, right now I'm pulling that one right here from Fandango. But now I can take the two transactions that I know I have and now run that. So now we've just run the first two rules through the aggregation pipeline. You're seeing the aggregation pipeline now take the transactions and give me a summary amount of all the transactions that were there. And then I say, okay, let's test whether or not that was greater than 20. And I'm going to get the same data set back, but everything is successful. So that's what the engine is doing. It's going through each one of these rule codes. It's running it through the aggregation pipeline or whatever the system is. Is it true? Yeah, okay, run the next one. To the point where eventually we come in here and we say if everything is true, then let's go pull an offer from this other collection, and then the client can go and render this however they want. So just to see this a little bit more, we could find some offers, let's say on that daily deal feed. Let's look for Miami, since I'm from Miami. So this is a bunch of inventory that I have for the daily deal that's updating all the time. So let's say that I was giving him restaurants. Say now we decided that today, he's dating now and he wants to look good, and we want to find an offer for him. So we think now he wants to go to the gym. It's a silly example, but you get the idea. So we're going to change this rule now to say use gym instead of restaurants here. So if all the rules are true, this time we don't want to give him a restaurant deal. We want to give him a deal where the category in Miami is gym. This is doing a real raw update of that JSON code. But now if everything works, there's the gym. So I was able on the fly decide today that based on this set of rules, if they're true, then we want to give that user these particular offers. And these offers could come from third party like you're seeing here. They can be internal offers, advice, anything that you're trying to target to that user based on their demographic or economic profile. And the cool thing is that now when Bob comes to me when I get back and says, I found this really cool feed and I want to use it today, we could go in now, configure the Iron.io tasks to bring that data in immediately, and then build rules around that data. We've made all of the data in the system actionable immediately, day one. And we're not limited to what we can bring in, and we're not limited to what we can display. Now, obviously, the client developers will have to look at the data that's coming back and format it the way they want if it's something really unique. But if we're able to, at least from a presentation standpoint, stay within the bounds of the presentation, we can target anything all day. And advice is usually a big one because they'll decide this week that something has happened in the economy and now we want to start giving people advice who have budgeted things around mortgage or something, right? There's a big mortgage thing, and anybody in the system that we can see that has a mortgage, let's start targeting this particular piece of advice. We can do that on the fly now. One thing I'm experimenting with is that I don't really have it working. But the idea is to be able to generate some of this code using a UI, which gets really tricky. Again, the client doesn't want me writing the rules. He wants someone that's able, at a business intelligence level, who can do some of it now, but ideally with this API to get it out to the consumer. I mean, imagine a marketing department being able to feed the system some data and then being able to write the rules for their system and not have to get developers involved to be able to do that. That's the ultimate goal, and that's tricky because you got to build tools that actually generate all this code behind the scenes, and I've been experimenting with some of that as well. So that's my talk, guys. That's what we're doing.
We've got time for a question.
How well do you think this will scale as far as number of users, number of databases you have, just as far as infrastructure goes?
I'm not. Another reason why I went with Mongo is because of their scalability. I mean, when I was working on the SQL Server, it was like, okay, I got to replicate this data. All right, great. Now I got to get a book on replication. Great. I have no clue what's going on. Great. So I was like, oh, we'll go to Azure. And then I was like, oh, I didn't structure my database right for Azure. I can't use identity fields. I've got to use GUIDs. Now I've got to rip my... And my head was about to explode. I don't want to deal with IT. To be honest with you, I don't want to deal with IT anymore. I just want to know I got to run a task, and there's some computing power over there, which is why I love Iron.io, right? I don't have to manage machines, operating systems, nothing. If 10,000 people hit the system, right now I can handle it. If they come up with 10,000 feeds for some crazy reason, I can handle it. It's like done for me. It's brilliant. For me, it's brilliant. Not have to really worry about IT anymore. So I'm not worried about the Mongo piece at all. Obviously, there's things that I have to learn about IT to really help scale it. And there's a lot of companies already who have gone through this pain. There's tons of white papers and articles on companies and how they've progressed with MongoDB to grow it and the mistakes they've made, which is great because if we read that stuff, we don't have to necessarily make the same mistakes. All right, done? All right.